In this lesson, we shall focus on geometry for grade 10. Question 8 to start with. K, L, M, N is a rhombus with diagonals intersecting at O. Right, now you can see that you have actually a couple of points here, and the points are as shown. So you can see K, L, M, and N. These are the vertices of a rhombus. Moreover, we actually can see that there are diagonals. The diagonals are the lines that run from one vertex to the opposite vertex. Those we call diagonals. So this is also a diagonal from K to from vertex K to vertex M. There's another diagonal from vertex L to vertex N. Right. Moreover, we have that LKM is 34 degrees. So we can actually be in a position to see that L, K, M equals 34 degrees. And here is the angle here. It is exactly 34 degrees. Here is the question. And the question has been asked, write down the size of the angle O1. We are looking at 8.1.1. We're interested in finding the size of the angle O1. Remember, we are dealing with what we call a rhombus. Have you ever done a rhombus before? Yes. Right? You've seen a rhombus before, Paul. Right. So a rhombus has all sides equal. So you can see KL is equal to, they've been marked equal here. So this side here, KL, is equal to the side LM, equals the side MN, equals the side NK. Okay. What is the size of the angle the examiner wants? The examiner is asking for the size of the angle O1. Write down the size of the angle O1. O1 is this one. What is the size of this angle here? Right. What do you think, Mpo? Before I give you the answer. What do you think?
It's 34 degrees.
Okay,
I'm not sure, guys.
okay, that's okay. That's okay. We are learning. Okay, because I just want to know how much you've learned. Okay, if you're dealing with what you call a rhombus, the diagonals are perpendicular to each other. Okay, we say the diagonals actually intersect at right angles. Dealing with a rhombus, we say it is a property. We say diagonals, right, intersect at right angles. Intersect at right angles. Right, if you don't want to say they intersect at right angles, they intersect at 90 degrees, the diagonals themselves are said to be orthogonal. We say they are orthogonal. Okay, right. Now, dealing with what we call orthogonal diagonals, because they are perpendicular to each other. They are just like what we call lines. If you have a line here and another line there, and these lines meet at right angles to each other, okay, we then say the two lines are orthogonal lines. And if we do not want to say they are orthogonal lines, a very, very popular narrative is to say they are perpendicular. Right, perpendicular. Right, if they're perpendicular, it means this angle is 90 degrees, that angle is 90 degrees, all of them are 90 degrees. So the examiner is just teasing us here, is asking us a stupid question. They're saying find, or rather write down the size of the angle O1, and clearly the angle O1 equals 90 degrees. What is the reason for this? The reason, because in geometry, if you say anything, if you give an answer, you give a statement, it must be supported by a reason. What is the reason? Right, diagonals of a rhombus. The reason is this one here, diagonals of a rhombus, you can write here. So you say diagonals. Right, diagonals of a rhombus. Right, of a rhombus intersect, or diagonals of a rhombus, yeah, or we can say intersect at 90 degrees to each other, right? Intersected 90 degrees. If you don't want to say that, you can also say that the diagonals, right? You can also say diagonals of a rhombus. Okay, I'm going to give you a test on these things. Diagonals of a rhombus are perpendicular, right? Diagonals of a rhombus are perpendicular to each other. Okay, so that is also another narrative that you can give there, perpendicular to each other. And this is what we have. Right, so we continue now to solve more problems, and we have the following here. So what is the answer to 8.1.1? The examiner said, write down the size of the angle O1, and we then say O1 is this one here. It is 90 degrees. If they could ask us the size of the angle O4, this angle here, it is also 90 degrees. What is the size of the angle O2? What do you think the size of the angle O2 is, Mpo? It's also 90.
90 degrees.
Well done. The size of the angle O3. Okay, today you are alone. Today you are alone, so yeah, you need to feel very free to talk if I ask a question. So the size of the angle O3 is also 90 degrees. So each of these angles here is 90 degrees. And we're done. Okay, I've written too much, I know, but take it easy. This lesson is being recorded, so yeah, I'm going to publish the recording at the end of our discussion. The next question is 8.1.2, and that is what we are answering. And the question is, calculate the size of the angle L1. The size of, here's L. And then L1 is this one here. The question is, what is the size of this angle here? What is the size of this? But how do we know? Okay, we always carry information forward. Whatever the examiner asked in the previous question, mark it in the diagram. It's going to prove very useful when you solve our problems. So now, in this case, this one we already know O1 is 90 degrees. They're saying what is the size of the angle L1? L is this one, L1 is this angle here. So what is the size of this angle here? Right, I know that this is way, way too easy. So let us look at these and think with caution. What do you think, Mpo? I always give you a chance before I give you the answer. I want to be fair to you. Because if I give you a chance, then you're going to be a smart kid. What do you think?
Akis, I didn't hear you. Someone called.
Please come again.
Oh,
okay, that's fine. All right, that's okay. So yeah, the size of the angle O1, L1, excuse me. So to find the size of the angle O1, because you already know how many angles here. You already know 34, but you also know O1. So that in the end, then you add this one, and this one. Right, so you're going to say that.
K plus O1.
Yes, well done. So, yes, so you're going to take K plus L1 plus O1 is equal to what? Is equal to 180 degrees.
Right. 180 and then bongwala sum of angles
in a triangle. Excellent, excellent. I like it. Right, so you're going to write angle L1, which is this one, plus angle O1, plus 34 degrees. Right, so we can always do that. So yeah, plus 34 degrees, can write like that. Plus 34 degrees, and this is equal to 180 degrees. What is the reason for these things here? This is the sum of angles in triangle. Well done. I love the reason. I love the reason. That is excellent. That is excellent stuff. Okay. So now we then obviously continue to then say now the angle L1 plus the angle O1 we know is how many degrees? It's 90 degrees plus 34 degrees, which is equal to 100 and what? And 80 degrees. Right, so what is then the size of the angle L1? So to find L1, we move everything to the other side. So we're going to say 180 degrees minus
124.
Okay, well done. Wow, you're so smart. Okay, you can even say 124 because if you these two give us 124. So
yeah,
good. That's correct. That's correct. And then what is 180 degrees minus 124? What is the answer? It is exactly 56 degrees. Well done. It is exactly 56 degrees. Okay, we got 56 degrees, but there are a couple of things also that remain very, very important. Also, I mean, we have this here, and the reason that we have written this equation is because of the sum of angles in triangle, but also the angle O1 equals 90 degrees. Why is the angle O1 equals 90 degrees? You just say proved. Proved in 8.1.1 above. Proved in 8.1.1 above. So yeah, I'm going to give you a little quiz after this. Proved in 1.1.1 above. Right. So yeah, what is the size of the angle L1? We've seen that it is exactly 56 degrees. What is the size of the angle O1? We've seen that O1 is 90 degrees. It remains to find to do 8.1.3. And so we shall solve right now 8.1.3. And to do 8.1.3, we want to find the size of K, N, M. K, N, M. K, N, M. So this one, the whole of it, this. The examiner is asking for that one, and they're saying, what is the size of that angle there? Right, so I know very well that we can easily find that one, but the question is, what is the size of the angle there? Okay, so we can easily find. Let's proceed to try that one. So the next thing is to look at 8.1.3 and want to calculate the size of the angle K and M. The size of the angle K and M. K and M. Right, so yeah, we want this one. Want that exactly. And obviously, I mean, there are lots of things we can do to find that angle there. And first things first, we take note of a couple of things here. That this angle here is equal to this angle there. So to do 8.1.3, we say the angle L1 is equal to the angle L2 because we've already got that this L1 is how many degrees? It's 56 degrees. So which means that also this one must be 56 degrees. So L1 equals L2, it is 56 degrees. Why is it the case? The diagonals bisect the angles. So now we then say diagonals of a rhombus bisect the angles. Right, diagonals of a rhombus. Right, diagonals of a rhombus bisect the angles. Right, diagonals of a rhombus bisect the angles. So because this one is a rhombus, this diagonal bisects the angle. So also this diagonal bisects. So if this angle is 34 degrees, also that one is going to be 34 degrees because this is a rhombus. But also now these angles here remain equal to each other. So the question then becomes, what is the size of this angle there? Okay, so the opposite angles of a rhombus are equal to each other. So this whole angle here is equals to the whole angle there. The question is, what do we then say about this? So we start and then say K and M. K and M. Right, so we have K and M is equal to K KLM. KLM. And this KLM is the whole angle here. So if it is the whole angle, now we must add this one and this one. So we must add 56, but we must also add another 56 because it's 56 and 56. And then 56 plus 56 gives us what? Right, 56 plus 56 gives us 112 degrees. You agree? Yes. Well done, Paul. Thank you so much for noting that. Because this is a rhombus. If it is a rhombus, if the examiner tells you it's a rhombus, they tell you in a test, in an exam, it means the opposite angles are equal. Okay, so that is something that you need to obviously take note of. So that, why is it that K angle, KNM is equal to angle KLM? Why is this angle here equals that angle there? Because these are opposite angles of a rhombus, right? So the reason you supply is that we have the opposite angles of a rhombus. Right, good. We have the opposite angles of a rhombus. So you have the opposite angles of a you can just say also, I mean, you don't need to write very correct, very complete English here. This is mathematics. So what you then say is these are opposite angles of rhombus. Opposite angles of rhombus. And then we know that if you have opposite angles of rhombus, then we understand, therefore, that this angle here is 112 degrees. The angle L1 is actually, we've already found the angle L1. We found it to be 56 degrees, and it's also in the diagram. What did you find the angle O1 to be? 90 degrees. Well done, Paul. Thank you so much. So we have answered all these questions here. These are past exam questions. They are not just questions I'm bringing to you. They are past exam questions, and therefore these remain very, very important. Very, very important. So we continue right now to solve more problems. Then we are looking for the next question. What is the next question? Right, given parallelogram PQRS, okay? Parallelogram PQRS. So you have P, Q, R, S. With the diagonals, PR, P, R, and Q, S. These are the diagonals of the rhombus, right? Of the parallelogram, right? Intersecting at M. They're intersecting at M. Because this one is not a rhombus, this one is a parallelogram. So these diagonals here intersect because they meet. To intersect is to meet at the point M. That is sort of their meeting point, because if you draw this line here, it's called a diagonal from one vertex to the opposite vertex, but also there's another diagonal here from one vertex to the opposite vertex. They actually meet at the point M, and therefore, if they intersect at the point M, there are a couple of things that remain extremely important for us to take note of. Prove that the diagonals bisect each other. Prove that the diagonals bisect each other. Right, so this is quite a heavy question. Very, very heavy question. Let us brace ourselves for an exciting calculation. So if this is the case, what then do we do? So we need to write down, need to prove that. So we present a proof, right? So to present a proof, we need to consider what is given. Right, what exactly is given? We have been given parallelogram. We have been given parallelogram PQRS, right, with diagonals. Right, with diagonals, right like that, with the diagonals, PR, right, with the diagonals, PR and there's a diagonal PR with the diagonals PR and QS with the diagonals PR and you can see PR and QS. Required to prove. Required to prove. What are we required to prove? We need to prove that the diagonals bisect each other. So to prove that the diagonals bisect each other, the word bisect means to divide into two equal parts. So then it means, therefore, we have PM is equal to MR. PM is equal to MR. And obviously, I mean, we need to prove this. We need to prove that PM is equal to MR. Right, so we continue right now and we present a proof. Right, we present a proof to this. And so what is the proof? So as part of the proof, we say in triangle. Right, in triangle PMS and triangle RMQ. Number one, you have that angle P1. So we're going to work in triangle PMS. P, M, S. So we're going to work in this triangle here. P, M, S. Okay, so we're going to work in this triangle here. But we're also going to work in the triangle RMQ. RMQ. So you're going to have this one here. Also, this triangle RMQ. RMQ. So that then in the end, you need to then say the angle P1 is equal to the angle R1. The angle P1 equals the angle R1. Why? Because this is a Z. And in the case of a Z, what do you call those angles in Paul? Yes, we call them alternate angles. We call them alternate angles. So these are alternate angles. Why are they alternate angles? So you write alternate angles and then supply a reason. Right, these are alternate angles, and then you supply you justify the alternate angles in terms of the parallel lines. To say you have alternate angles, then you must have some parallel lines, and therefore the parallel lines are PS. PS is parallel to QR. PS is parallel to QR. Then number two, you have that the angle S1, the angle S1, this one. So in other words, yes, the angle this one is equal to this one. So what do you think the angle S1 is equal to, Paul? It's equal to Q1. Well done. It's equal to Q1. Why is it equal to Q1? Does it form a Z also? Yes, there is a Z. So we have alternate angles. If they're alternate angles, which lines are parallel then? Which means you have PS is parallel to QR. PS is parallel to QR. And then now we have number three. Number three, we have another fact, because we're trying to prove that PM is equal to MR. Right, so to actually get to that point, but we are sure that PS, right, line PS is equal to QR. We are sure that line PS is equal to QR. Why is this the case? These are opposite sides. Right, these are opposite sides. So yes, so in other words, we say that the opposite, right? The opposite sides, okay, opposite sides, palm, opposite sides, parallelogram are equal. Can write like this. Opposite sides, palm are equal. So the PS is equal to QR. Okay. And then now you need three things. So you need this angle, P1 is equal to the angle R1. The angle S1 is equal to the angle Q1. And then we have PS is equal to QR. Okay, therefore, triangle PMS is equal to triangle RMQ is congruent. So the triangle PMS is congruent to triangle RMQ. Why are these congruent? They are congruent because of the reasons that we can state. So we have angle, side. So you have here angle, side, angle, side. And this implies that, this implies that because this triangle PMS is congruent to triangle RMQ, then you are able to say that even the corresponding sides are equal to each other. So that this implies that the line segment PM is equal to the line segment MR. So you have that PM is equal to MR, right, that way. So we have exactly that there as stated. So, right, and also, so you have that PM is equal to MR, but also you have that PM is equal to MR, PM equals MR, and also you have that MS. MS is equal to, yes, MS is equal to, MS is equal to MQ. Right, MS is equal to MQ, like that. So these are the things that, so in other words, the diagonals here, what they do is they most certainly bisect each other. Okay, because these triangles are congruent triangles, and therefore you have that your PM is MR, but also you have that your MS is MQ. Okay, this is a proof. So this proof requires a lot of reasoning. So you must practice this proof so that you are good at proving things, because that is what we need to do. We need to learn and learn and learn so that we can become the best we can be. But we continue right now to look at more problems. The next question. Right, so this is obviously what we've just done. Here's another question. And this question here focuses on a parallelogram. So in other words, in the diagram, ABCD is a parallelogram with diagonals intersecting at E. So you have A, because it's A, B, C, D. So you have A, B. I want to just mark these here. So I want to just tick them accordingly. So you have A, B, right? A, B, C, D. Right, in the diagram, A, B, C, D is a parallelogram with diagonals intersecting at E. Here the diagonals intersecting at E. The diagonals of parallelogram DECF intersect at G. Okay, the diagonals of parallelogram DE. D. Right? E. Because this is like DECF. So you have D, E, C, F intersected G. The diagonals of parallelogram, so there are lots of parallelograms here, Right, so there's another parallelogram. So we studied a parallelogram A, B, C, D, but there's another parallelogram that the examiner is giving to us in D, E, C, F. Right, so you have D, E, C, F, and obviously the diagonals intersect at the point G, but also you have the diagonals of parallelogram F, G, C, H. Right, the diagonals of parallelogram F, G, C, H. Right, so if you look at the diagonals of parallelogram and you're able to see it's F, G, C, H, intersect at K. So there's also this one here, this parallelogram, a small one, this F, G, C, H. Right, F, G, C, H. They intersect at K. Right, you have a question, Paul? No question.
Hi, this diagram is two. It has a inalili parallel
Yes, inality paragraph. Yes, definitely. Because the examiner gave us, because this is a past exam question, but they gave us A, B, C, D. So there's A, B, C, D as a parallelogram with diagonals intersecting at E. The diagonals of parallelogram D, E, C, F. There's also D, E, C, F. They intersect at G. The diagonals of parallelogram F, G, C, H. Right, F, G, C, H intersected what? At K. Right, prove that DB is equal to 4KC. Prove that, so you have D here, and then you have B there. So prove that DB is equal to 4KC. So you have DB is equal to 4K is this one, and C is that one. Right, so let us prove this and see what the examiner has in store for us. So we look at these very carefully and we reason and see what more we can have here. Right, so to prove that DB is equal to 4KC, we proceed as follows to prove this 8.3 result. So first things first, we actually are able to realize that DB is equal to twice DE. DB is equal to 2 times DE. Okay, because we have already, because this is a parallelogram. So this these diagonals bisect each other so that this one here and this one here, this is like the middle point, the midpoint. So that now if you take the whole of DB, it is 2 times the distance if you move from D to E. So you move from D to E, and then you multiply it by 2. So from D to E, if you multiply it by 2, then it is the same as saying from D to B, like that. Okay, so we supply the reason for this. So the reason for that is that DE is equal to EB. Okay, because these diagonals of a parallelogram, what they do is they bisect each other. Then we look at the next point, and the next point is to focus on DE. Okay. Right, we note that DE itself is also equal to FC. Right, we note that DE is equal to FC because there's another parallelogram here. This one. There's another parallelogram where they've put like 3 arrows, and then they've put 1, 2, 3, 4 arrows, 4 arrows. So there's another parallelogram. But what we're able to see is that now DE is equal to FC because the opposite sides of a parallelogram are equal to each other. So that now DE is equal to FC. Is equal to FC. And why is this the case? You have the opposite. Write the opposite sides of parallelogram. Right. And once you say the opposite sides of parallelogram, we understand that to actually mean that the opposite sides of a parallelogram are equal to each other. Next. But now we have the FC. Right, FC is equal to, right, here it's from F to C, is equal to 2 times KC. So we have FC is equal to 2 times K here, C. Okay, look at this, 2 times KC, because once again, why is the FC? From F to C, FC is 2 times KC. Okay, because these diagonals cut each other in half. They bisect each other. So that if you move from K to C, it is the same as moving from K. If you move from F to C, it's the same as moving from K to C and multiplying by 2. So if you say from K to C multiplied by 2, it's the same as from F to C. And the reason is that FK is equal to KC. FK is equal to KC. And also, now if you look at DE, DE is equal to 2 times KC. So DE is equal to 2 times KC. Let us look at this, but look at this very, very carefully. So if we say DE is 2 times KC, why is this the case? Why is this the case? It is the case because you have DE is equal to FC. It's because DE is equal to FC. Right, so at this point, you have that your DE is 2 times KC. Right, the reason is that DE is equal to FC. Right, so let us check that one. If we say DE itself is equal to FC. So DE is equal to FC because we already know that FC is 2 KC. FC is 2 KC. But DE itself is equal to FC. So that DE is 2 KC. Okay, try to understand that. Try to understand that. There's just too many things we're saying here. Moreover, there is DB. DB is equal to, okay, so we come here. Now there's this equation that we have written down. Okay, this is geometry for you. This is one equation we've written down. So it's DB equals 2DE. What is DE? DE is here. DE is 2 times KC. 2 times KC. Why is this the case? We have DB is equal to 2 times DE. 2 times DE. So if you look at DB is 2 times DE, which is this one here. So we have written here DB equals 2 times DE. Okay, obviously there's a lot of details here that you need to pay particular attention to. Quite a long question in geometry. And then 2 times 2 is 4 KC. And this is what we're supposed to prove, because they said prove that dB is equal to 4kc. dB is equal to 4kc. Okay, it was quite a very involving question, this. And you need to prepare for war in these exams. You need to prepare for war, because these exams are not at all a joke, but they're there to strengthen your ability to solve questions. And therefore, it's very, very important to ensure that you're on point, but also you must actually make sure that you understand what is happening here. So think about this, Mpor, and make sure that you follow what is happening. You reflect on this. You're going to play this video. We're going to send you the recording of this lesson, and you're going to play around with it. You're going to watch it during your own leisure. Okay, so you watch the recording of the video and practice this. First, you watch. Make sure you are attentive, you're watching, you are listening, and in the end, you try the question on your own to see if you can be able to go through these steps. Very long geometric proof there. Let's go to the next question. Right. So now I will actually look at a couple of other questions that you need to practice with. For example, right. Factorizing, eh? All right. Okay, good. Right. So yeah, let us look at questions that require you to sort of factorize. Right. Okay, so we're gonna spend some time on factorization. So we can say, for example, factorize the following. Right. Let us say you are required to factorize. Right. You're required to factorize ax plus bx. What do you think are the factors of this? What do you think are the factors of this? Right, so obviously you need to look for something we call the highest common factor. HCF, we call that the highest common factor. Right, so that at this point, the highest common factor, X appears here, X appears there. So X is common. If X is common, then you pull it out. When you pull it out, you cross it out like this. Then you are left with A plus B. And these are the factors of this particular expression. All right, so I'm going to give you more factors of actually, obviously, a wide range of expressions that you need to consider. Okay, so now let us look at the following. So if we say to you, we need to factorize, let me write it in red, x cubed minus y cubed. What are the factors of this? X cubed minus y cubed. What are the factors of this? For example.
3.
I'm just teasing you.
1.
Okay. What do you think?
3 or 1.
Okay, 3 or 1. Okay, so what we do is you cover the 3. Like delete 3 and delete 3. Then you are left with x minus y. You square x. These times minus. xy plus y squared. Just look at the next one. So these are the factors. So umwala x minus y. Okay, so you like pretend as if the 3 and 3 are not there. Okay, yeah. So and when this happens, this is called the difference of two cubes. We call this one the difference difference of two cubes. Difference of two, because, what is the difference? A difference is the result after subtraction. Are we together? Result after subtraction. So, but we can also give you x cubed plus, sometimes it can be a plus here. X cubed plus y cubed. What is the result? If we give you x cubed plus y cubed, what is the answer to, what are the factors of that?
Open bracket,
Yes,
x
open bracket.
plus
X plus
y,
y.
and then x squared.
And then you have x squared.
Okay,
Yeah, so you
minus.
change. It's a minus. Well done. It's a minus because now you then say you write x squared, then you, because these are both plus, you multiply x and y, you get xy, but you put a minus, so it's minus xy. Then you put plus what? Plus y squared, like so.
Okay.
Okay, there's something we call the difference, the difference of two squares. What do you understand by the difference of two squares? Right, the difference of two squares. Right, so the difference of two squares would be if we give you x squared minus y squared. What are the factors of this? X squared minus y squared, what are the factors of this?
Open bracket,
Open bracket,
and then x minus
X minus
y,
x minus y, well done.
open bracket,
Mm-hmm.
x plus xy.
Good, like that.
Oh, you wanna know?
Yes, we want to solve because this one is having squares. It's like x squared minus y squared.
Yes,
And yes, so we write it like this. But we're going to give you like some examples. Let's give some examples here. Let us give some examples that we can use to practice together. Right, to give a couple of examples, let us proceed as follows. For example, right, because we've already solved this, we're going to use this space for us to practice a little bit more and spend time on factorization. Here is an example. Yes?
Compare to a 2m squared minus 5m plus 3.
Okay, please give it again. You said it's what?
2m squared.
2m squared, like this.
Yeah, minus 5m.
Minus 5m. Okay, good.
Plus 3.
Is it plus 3?
Yeah.
Okay, plus 3, like this.
Yeah.
Okay, good. Let us look at these. So obviously now we need to factorize this. And to factorize these, there are a couple of ways that we can use to factorize these. But how to proceed to factorize this? We factorize these as follows. We need to, now to factorize, we multiply this with that. We multiply 2 times 3, like 2m squared times 3. What is 2m squared times 3, for example? What is 2m squared times 3, for example?
12.
Right, or like, what is 2? Yeah, I mean, like 2 times 3. Right, so 2 times 3 is what? Right, 2 times 3, yeah, it's 6. Well done, okay? So 2 times 3 is what? Is exactly 6.
And
So,
then how 2 squared times 3 is 12.
yes, so you multiply the 2m squared and the 3, and you multiply, if you multiply the 2m squared and 3, is equal to 6m squared. Okay, you have 6m squared like this. Okay, if you have 6m squared, then you actually therefore look for the factors of 6 that give minus 5. There are two numbers. When you multiply, give 6. But when you add them up, give minus 5. What are those numbers? And those numbers, so those numbers would be minus 2m, or sort of expressions, minus 2m and minus 3m. Because minus 2m, okay, m times m is m squared, but minus 2 times minus 3 is what? Is 6. But what is minus 2 minus 3? Minus 2 minus 3 is minus 5.
Yeah,
So that,
negative 5.
yes, it's negative 5. So that now in the place of negative 5, you put negative 2m, negative 3m plus 3, like this. That's what you write.
That's the final answer.
Well, it's not the final answer yet, but it is a step towards the final answer. Then now you're going to consider these two and then take the highest common factor. Like 2 is a common factor, so you write it. M and M. But here there's M squared and M. So you take the smallest power, because if there's M alone, it means that the power is what? Is 1. You can imagine like that. So obviously, what you then do is you take out the M. So if you take 2 is common here in these two terms. 2 is common, and then M is also common, so that you have M minus 1. Because when you take out the 2 as a common factor, you cross this out. Right. And then now you take out the M. So you cross this M and then you cross this one. Right. And if you cross this M, because you pulled out 1m, and this is m squared, so there are 2 factors of m, and then you're left with 1 factor of m. Right. So you have this. And then here, you take out the common factor. Common factor is what? 3 is a common factor, but take out with the negative. So if you take out minus 3 as a common factor, you are left with m, so you cross it out like this. So if you take out the 3, and then in the place of this one, you're left with 1. But because you are pulling out a negative, this one is going to be negative. So that when you multiply negative times negative, negative times negative gives a positive. And then minus 3 times m gives minus 3m. Now we continue. So you have the m minus 1, m minus 1. So it's a common factor. M minus 1. 2m minus 3. Like that. So you have the m minus 1 as a common factor, and then it's m minus 1, m minus 1. So when you take out the m minus 1 as a common factor, you cross this out and you cross this out, because we are taking the m minus 1 as a common factor. Then you're going to be left with 2m minus 3. Yeah. So this is the answer. This is the answer. But obviously, we're going to give you like more problems to try on this factorization thing. So let us continue and do more of this factorization so that you can be a very good student. And we continue with more factorizations. Right. And we're going to look at how the factorization is done, because factorization is part of the grade, is part of the grade 10 syllabus. And so now we're going to look at how in the exams you are expected to learn factorization and become a superstar. So we continue. Right, we continue. So the next thing. Right, so let us do this. Let us use this space here. So I'm going to clean this up. Right, and clean this up now, we're going to put another question that is on factorization, and we shall make sure that we practice factorization together so that we can be very good people. We can be good citizens of this country. Right, we can be good citizens of this country. And we continue and we do the following. Right, so We continue as follows. We continue as follows. Let us look at the following question. Let us look at the following question. Right, factorize. That is the question. It says factorize. And you have this question here. We have 4x minus x cubed. We have 4x minus x cubed. Okay, good. Right, and there's Tenula there trying to join us, which is excellent. So what do you think the factors of these are, Paul? What do you think the factors of these are? What are the factors of these?
X.
Yeah, we need to factorize, right? So what do we do?
Yeah.
So we need to look for what is common. What is
X is
common?
common.
X is common because there's X here and there's also X there. So in other words, we're going to pull out X. And X is the only thing that's common because there's 4 here, but there's no other 4 there. So 4 is not common. But X is common. And when we pull out, we cross this one out and we cross this one, we have a 2 there. So that we have 4 minus x squared. Because if you pull out one x from the x cubed, you're left with what? You're left with x squared. Okay, if you pull out one x, you factor out one x, then you cross it out here so that you are left with only 4. Okay, then what do we do now, Paul? What do you think? What do you think we do? What do you think we do?
Bracket.
Open bracket, okay, yeah. Open bracket.
And then X 4x. 4 minus x
Okay,
plus
so
bracket.
this one, yeah, this one you can write it as 4 is 2 squared minus x squared. 4 is like 2 squared because 2 squared is like 2 times 2, which is 4, right?
Yeah.
So now, what do we call this one? A square minus a square. It's called the difference of 2 squares. What did you say about x squared minus y squared? What are the factors of x squared minus y squared? What are the factors of x squared minus y squared?
X minus y.
X minus y, and then x plus what? X plus y.
Y.
Okay, so these are the factors of this. So it's the same here. So now, because it's squares, you'll have 2 pairs of brackets like this, 2 pairs of parentheses. And then now you cover the exponents 2 and 2, and then you're left with 2 minus what? 2 minus x. And then you also have 2 plus what? 2 plus x, like that. 2 plus x, like that. So these are the factors. So any question, Paul, or any suggestion, any contribution, what do you think you can contribute to this grade 10 mathematics? What do you think you can contribute to this one? Okay. All right, yes. Dishebe then, because I'm going to give you like more. Okay, let me also give you another one. Right, so if I give you another one, for example, okay, you gave us this one, but I can give you a different one. And obviously, because we're trying to make sure that you practice and you understand everything. But now let us look at this particular one. You need to factorize, and that is the question. Right, you need to factorize. Right, y minus xy plus x minus 1. What are the factors of this one? What are the factors of this one? Yeah. Have you ever seen something like this before?
No.
Okay. Right. But now to deal with this one, we continue with the fact that we need to factorize this. And to factorize this, what do we do?
You open bracket.
Okay, open bracket. Okay, first and foremost, what is common here in the first two terms? What is common?
Y.
Y is common. Well done. So you factor out y and then you cross this y out, you cross this one out. When you cross this one, because there was only one y here, you're left with one. And then now you factored this y out and you're left with like 1 next to the x. So it's only just x. And then when you get to this point, this one is 1 minus x. So you must make this one 1 minus x. How do you make it 1 minus x, this one?
You transpose.
Yeah, you need to sort of transpose things. But what you do is, because this one is positive and this one is negative. So what you do is you factor out a negative. When you factor out a negative, this one that is negative is going to lose. It's going to lose its negative, and then it's going to be plus. The x, which was positive, becomes what? Becomes negative. We have 1 minus x, 1 minus x. Okay, if you have 1 minus x and 1 minus x, then what do you get? 1 minus x and 1 minus x, then you have y minus, then, okay,
1.
Yes, you have y minus 1, because if you pull out the, if you pull out the 1 minus x, then you're left with the y here, but you're left with 1 there. And so these are the factors, and this is the answer to this question. Okay. Uh-huh.
Yeah.
Okay.
Open bracket.
Okay, right. I'm just gonna actually write it here so that you're able to okay, right. Okay, yeah, please give me the question. You're saying open bracket, right? Open bracket.
Bracket.
Okay, I'll close the bracket. Let me remove the bracket, okay? Then what do we do?
15x squared minus.
Is it 1, 5? 1, 5 or 1, 6?
Yeah, 1, 5.
1, 5 x squared, okay? Yeah.
Minus 18xy.
Minus 18 xy, like this.
Yeah, plus 3y squared.
Plus 3y squared.
Yeah.
Good. And we need to factorize this one, right?
Yeah.
Right, good. And to factorize this one is very, very interesting, but also very, very easy. First things first, you need to ask yourself, is there a common factor? Is there a number that divides 15, that divides 18, and that divides 3? What number is that one? There's a number that divides 3, that goes into 18, but it also goes into 15. That number is 3 itself, because 15 is 5 times 3. So 15 is a factor of 3. Okay? 18 is 6 times 3. 18 is 6 times what? 18 is 6 times 3. Okay, so, yeah. So you factor out 3 here. What is 15 divided by 3? So you divide. 15 divided by 3 is what? It's a 5. It's a 5. And then what is 18 divided by 3? You just put the negative here. 18 divided by 3 is what? 6. Well done.
6xy.
XY. And then you divide 3 by 3. When you factor out something, you divide inside. So it's 1. And then it's 1y squared. So we just going to write only
y squared.
Yes, like that.
Y squared.
Like that. Okay, we always do this when we factorize to reduce the numbers because these numbers are very large. Next, what we then do is we multiply 5 with 1. We multiply like the coefficients. So you multiply 5. In principle, you multiply 5x squared with y squared. Multiply 5x squared with y squared. Okay, you can just say multiply 5 and 1, the coefficients in front of these variables. And then now this is going to give you 5x squared y squared. 5x squared what? Y squared.
Y squared.
And then what you do now? You look for the factors of 5. Factors of 5 that give -6. There are two numbers. When you multiply them, we get +5. But when you add them, we get -6. What are those numbers?
How do you put in
If there are two numbers, if we are multiplier, we get 5. But when we add them, those numbers, we get -6. What are those numbers? Those numbers are -5. Because now you look at this is like xy, this. So you put xy and then -1 xy. But yeah, -1 xy. -1 xy, you just put -xy. -1 xy is actually -xy. So that then in the end, what you're getting is as follows. Okay, so it's what is -5 minus 1? -5 minus 1 is what? -5 minus 1 is -6. -5 minus 1, when you just add them up, you get -6. But -5, -5 times -1 is what? Is +5. Are we together?
Yeah, keep positive.
Keep positive because negative times negative is positive, isn't it? Okay, good. So that now you put the 3 here. So you're going to put 5x squared. Then these numbers, you put them here. Because now you're going to put here 5xy. This 5xy, you're going to put it there. Then now you also put -xy. Then you also put what? Y squared. Like that. And when we continue, then at this point, we are able to, okay, -5 minus 1 is -6. -5 minus 1 is -6. Okay, we have the 3 here. And then now you must pull out the highest common factor that is common in the first 2 terms. What is common here? You can see that 5 is common. So you cross it out because you pulled it out. Then there's also what? X. This one is there's x here and there's x squared there. So x is common. So you're going to cross out this x. And then here, this one is x squared. There's 2 factors of x. And then if you factor out 1 factor, and then we're left with only 1 x factor there of x. So now, then after you crossed out the 5, you crossed out, and then you're left with x to the power 1. X to the power 1 is just only what? Just only x. You pulled out the 5 and the x. You're left with what? The -y. Okay, so here you pull out the y. What is common? What is common here in these two? What is common here?
Y.
Y is common. Right. So if you have y that is common, and so you can pull out the y. So if you pull out the y, if you want, you can pull out the y like this. And if you pull out the y, then this x is negative. And then if you pull out the y, there are 2 of them, so you're left with only 1. You're left with only 1 there. And then you continue. So now this one is x minus y, but this one is -x plus y. So we must make this one to be the same as this. We must make them the same. So now, to make them the same, how do we then make them the same? Because this one is x minus y. But this one is minus x plus y. So how can you make them the same, these? It means that here, for the x, we must factor out a negative so that you have a minus, and then you have x minus y, like that. Because you factor out a negative, and then it becomes a negative y, and we have x minus y. So if you have the x minus y, what do we do? So this one is crossed out. If this one is crossed out, then we have x minus y. Because x minus y is a common factor, but there's a 3 outside already. But this x minus y, we pull it out. And if we pull it out, we cross it out. And when we cross it out, you are left with what? You are left with 5x
x minus y.
Minus y. Well done. And therefore, this is the answer. This is the answer. So we are done with the factorization of this. So any question that you actually do not understand the book? Any question that you do not understand? Or is anything? Yes?
O class niya.
Uh-huh.
Written 15 open bracket 2 squared minus 6y plus 3y squared close bracket. And then kota sangwala in 15 open bracket 3 minus 3y close bracket open bracket x plus 3. Then kota sa final answer angwala x equals to 3 or x equals to negative 3.
Okay, good. Okay, yeah, I can hear you there. Okay, what was the original question? I mean, was it just 15x squared minus 18xy plus 3y squared? Was it equal to anything?
Million affair.
Million affair, right? Okay, right.
Yeah.
Obviously, there are many ways to do it. For example, let's look at the answer we got. This answer that we got can be written differently. Like, what can you do with this answer? So with this answer, you have a 3 here. So if you have a 3 here, you can put the 5x minus y and then have x minus y. So you can commute. You can switch the order of multiplication here. Once you switch the order of multiplication, then you have, what is 3 times 5? 3 times 5 is 15. 3 times 5 is 15. Then we have 3 minus y. So then we have minus 3y, and then we have x minus y. So they might have written the answer like this. They might have written the answer like, what did they write? Did they write 15? Did they write the answer like this? Did they write like 15x minus 3y, open bracket, x minus y? Did they do something like that?
X equals to 3 or x equals to negative 3.
Okay, Bangwetsi, like x equals 3 or x equals negative 3?
Yeah.
Okay, yeah. Right, so let us look at this and think about it. Yeah, but obviously, I mean, it doesn't follow that because we're not solving here. Okay, this question did not have an equal sign in the beginning. This was not equal to anything, you know. Since it was not equal to anything, what do we then do? What do we then do? Okay, never mind, but this is going to be the answer. So this is the answer, but this is also the answer.
Okay.
Please come again.
Kuparete ya solver.
Yeah, we'll solve it, eh? Okay, good. Yeah, let me just take that question now solver just now. Let us do that. Right. Let's just clean this up. Right, so we're going to read out the question that must be solved, and we're going to solve it together right now and see what more we can do so that we can be better people, we can be good students, and we can enjoy ourselves. Right, so we're good, we're good, we're good, we're good, we're good, most definitely. Okay, I'm just cleaning this up, just cleaning this up, just cleaning this up. Okay, let us look at, okay, what is the question?
18 to the power of x.
18 to the power of x.
Times ya
Okay,
bona ba e ngotse ka dot.
okay, right, all right, that's fine. This, just write it that way. So you have 18 to the power x, is it like this?
Yeah.
Okay,
And then times ya bona ba e ngotse ka dot.
got dots, ne? Okay,
Yeah.
okay,
8 to the power of x minus 1.
okay. Is it 8
Yeah, 8 to the
to
power
the
of
power of
x.
x minus 1, like this?
Yeah, over.
Over, is it like this?
Yeah.
Okay,
9.
9
9 to the power of x minus 1.
to the power of x minus 1.
Dot half.
Dot,
4.
okay, is it dot 4? Okay,
Yeah.
right, okay, that's fine. Dot 4,
To the power of 2x minus 1.
to the power of 2x minus 1,
Yeah, it's a location.
Okay, is it all? If it's so, is it all?
Yeah, it's a location.
All right, and obviously the question would say, at this point, it would say simplify. It would say what? Simplify. So how do we simplify this? How do we simplify this? Right, to simplify this, there are a couple of things we need to consider. First things first, you need to look at the numbers that we have and attempt to make these numbers to have, or these expressions to have the same base. The same base. Right, first things first, let us look at the number 18. Right, so the number 18 has two factors that are of interest, at least to us, but yeah, they're much more than that. But the two factors, like, you can see that the factors of 18 are what? Or actually 2 and 9. Right, so the factors of 18 are 2 times 9 to the power x. The 8 is the same as 2 to the power. Is the same as 2 to the power 3. Okay, yeah, just 1 minute. Okay, so this one is 2 times 9 to the power x, which means this one is 2 to the power 3 to the power x minus 1. Okay, this one is 3 to the power 2 to the power x minus 1. This 4 is the same as 2 to the power 2, all to the power 2x minus 1. Right, so what we're then getting here is this is 2 to the power x times 9 to the power x. This is 2 to the power, then you have 3 open bracket here. Right, so this is going to be 3, so you can just expand this one. 3 times 1, or 3 times x is a 3x, and 3 times minus 1 is, yeah, it's minus 3, and you divide by, so you have 3 here. 2 times x is 2x minus 2, and you multiply that by 2 to the power. Now, 2 times 2x, it's a 4x minus 2. It's a 4x minus 2, so that the number 9 is the only one that must be changed to the base 3. So you have 2 to the power x. The number 9 is 3 to the power 2, but there's already an x there. So this one is 2 to the power 3x minus 2. Right, and so what we're then getting is as follows. So which is 3 to the power 2x minus 2, 2 to the power 4x minus 2. So the bases here, that we have two bases here. There's base 2 and base what? Base 3. So what you then do is you take the base 2 and you add everything, the powers of 2. Okay, so there is an x here, x minus 2. Right, so you have an x here and then x minus 3x minus 2. And then now,
3. Why 3 to the power of 2x again?
Yeah, because Leon Kenya will include it, but we are beginning with the 2 now. Because 2 is 2 to the power x, and then there's 2 to the power 3x minus 2. So we're dealing with the 2. 2 has power x, but 2 also has power 3x minus 2. But also 2 has power 4x minus 2. But you bring it to the top, so it's going to be minus 4x, and then it's going to be plus 2. And then you multiply it by, then you have a 3. 3 to the power 2x. And then now in 3 to the power 2x, then there's another 3 here. There's a 3 here, and there's also another 3 there. This 3 is at the bottom, so you subtract 2x and you add 2. Okay, so we continue.
Something.
Yes, please.
For negative 4x plus 2 is okay. Or winkile ko tan.
Yeah, because it was here at the bottom. But now it was like 4x. Then if we move it to the top, it becomes negative. So it becomes minus 4x. This was minus 2 at the bottom. If we move it to the top, it becomes positive. So if you move it to the top, it changes sign, those exponents. Like this one. Here at the top, it was only 3 to the power 2x for 3. 3 to the power 2x. But now in the bottom here, you had 3 to the power 2x minus 2. So there's 2x here, and then we move this one to the top, so it's going to become minus 2x. Then we have minus 2, you move it to the top, it becomes plus what? Yeah. Plus 2. All together. And then you have 2 here. And then when you add all these things, you have, what is x plus 3x? 4x, right, 4x. And then there's 4x minus 4x. So they cancel out. And then you have minus 2 plus 2. What is minus 2 plus 2? Minus 2 plus 2 is what? Is 0. Okay, so this minus 2 also, this minus 2 cancels out the minus 2. This minus 2 cancels out. And then you have 3 here. What is 2x minus 2x? It's 0. And then you are left with a 2 here. Okay, so what is 2 to the power 0?
1.
Is 1. And then 3 to the power 2 is what? It's 9. Right. It's like 3 times 3. Yeah, it's like 3 times 3. 3 to the power 2 is like 3 times 3, which is 9. What is 1 times 9? Okay. 9. So the answer to this question is what? Is 9. Any question? Any suggestion? If you have a suggestion, you let us know. That please come again. Yeah, Sheba Engwe. Just look for another one so that we can try the next question and make sure that you understand everything and all these questions that are bothering you, you are able to solve them, because I'm going to give you a homework at the end of this discussion, but it is very important that you are able to solve these particular questions over here. Right. It's very important that... Yes.
If
Okay.
a trigonometry.
Okay. Yeah, what?
Trigonometry.
Trigonometry. Okay, that's fine. Are you saying trigonometry? Let me just clean up. So you have a specific trigonometry question. Oh, I can give you some questions. I don't know which one. Do you have some questions in front of you? Oh, okay,
Okay,
that's fine.
fine.
Yeah, that's fine. The questions. I'll give you some questions. So that now you can learn how to solve trigonometry questions. Right, so obviously we need to make sure that your trigonometry is also improved and is enhanced. Let us look at some trigonometry questions here, and we start looking at the trigonometry questions as follows. Here is trigonometry, and it is as follows. Right. So if you look at these very carefully, you have the following. Right. So if you have lots and lots of trig as follows, let me just give you some trig. Right. Here's one question. Right. It says that if 4 cot theta plus 3 is equal to 0, where 0 degrees is less than theta less than 180 degrees. If 4 cot theta plus 3 is equal to 0, the question says find, right, find cosine theta or cos theta. This is the question. What do we do here? We think about these together. So we present a solution to this. Right, so to present a solution to this, we have the following, which is for the cot of theta. Right, so you have 4, the cotangent of theta plus 3 equals 0. Which means that you have the cotangent of theta, which is minus 3 over 4. Minus 3 over 4. So what then do we do here? You draw a diagram. A diagram that is going to have theta between 0 degrees and 180 degrees. A quadrant in which the cotangent of theta is negative. Right, so this is what you do. Right, this is what you do. And what we then do here, so we continue to draw. Like this. We sketch like this. Theta. Right, so now we know that there's something called the cast rule. What does cast mean? Right, so here we have all positive. Here you have cosine theta, tan theta, sine theta here, sine theta, sine theta. Okay. So that now at this point, opposite, yeah. So now there's something we call SOHCAHTOA. What is SOHCAHTOA? Right, you know SOHCAHTOA. So that sine is opposite over hypotenuse. Cosine or cos is adjacent of hypotenuse. Tan is opposite over adjacent. Okay, good. When you get to this point, we have that the cotangent is the reciprocal. So in other words, this one goes with cosec theta. This one goes with sec theta. This one goes with cot theta. So that when you're here, the cot is the reciprocal, because the reciprocal of the tangent. Okay, the tangent is opposite over adjacent. So cotangent is going to be adjacent over opposite. So we come here and we actually are able to see the adjacent. So you come here, so it's -3. Opposite is 4. Okay, this triangle is called the 3, 4, 5 triangle. We call it the 3, 4, 5. But we can also be able to find that because we use Pythagoras theorem to say x squared plus y squared is what? Is actually r squared. Yes, this is Pythagoras. Right, and then if this is Pythagoras, what is our x here? Our x is -3. You square this. What is our y? Is 4 squared, which is r squared. What is 3 squared? Is 9 plus 16, which is r squared. What is 9 plus 16? Is 25, which is equal to r squared. And we continue in this direction. So when you have 25 is r squared, you take the square root like this. What is the square root of 25? It is 5 equals
5.
r. Right, so that r is equal to 5. The examiner wants us to find something. What do they want us to find here? They want us to find cosine theta. Right, so cosine theta now is going to be found here. So what is cosine theta? So you write that cosine theta, cosine is adjacent of hypotenuse. This is theta, adjacent of hypotenuse, which is -3. The hypotenuse is 5. Adjacent of hypotenuse is -3 over 5. -3 over 5. Adjacent of hypotenuse, which is -3 over 5. -3 over 5. So now we are doing more trigonometry. We are doing more and more trigonometry. Let's look at this trigonometry question. Let's look at this trigonometry question. Right, in the next question, we're going to simplify some trigonometric expression. Right, and this trigonometric expression will be as follows. Let us see what we can do to simplify these trigonometric expressions. All right, I'm going to put one trigonometric expression on the board, and it is as follows. Right, so if you have, right, to say simplify. Simplify. Okay, so you have cosine theta, cosine 30 degrees. And then you have the tangent of 60 degrees plus cosec squared of 45 degrees, sine squared of 60 degrees. Right, we have cosine of 30 degrees, the tangent of 60 degrees, plus the cosecant of 45 degrees, the sine squared of 60 degrees. Right, so what do we get here, actually? What are we able to get at this point? Okay, what is What is cosine 30 degrees? And we ask that question. So we have a couple of triangles that you need to learn. Okay, let's look at these. Okay, let's see. Okay, if this one is a let's look at the 30 degrees, and then you have 60 degrees here, you have 30 degrees here, and then you have 2, the square root of 3 and 1. And then we have 60, 45. 45 degrees, you have the square root of 2, 1, 1. 90 degrees, 90 degrees. Okay, these are called the special triangles. These are called special triangles. Right, these are called special triangles. Right, so to simplify these, we proceed as follows. So now if you have the cosine of 30 degrees, the cosine of 30 degrees, right? So what is cosine 30? But now to find the cosine of 30 degrees, you must remember what we call saw, car, tower. Right, now let us come to this. Now we want to find like the cosine of 30 degrees. Right, cosine 30 degrees. Now 30 degrees is this one in this triangle. It is this one. So cosine 30 degrees now is cosine is adjacent over hypotenuse from SOHCAHTOA, adjacent over hypotenuse. If this one is 30 degrees, then what is the adjacent side? Right, this is 30 degrees. The adjacent side is what? Okay, yeah, because now 2 is the hypotenuse because it is opposite the 90 degree angle.
Square root of 3.
Square root of 3, well done. So the square root of 3 is the adjacent side. So you're going to have here the square root of 3, then, yeah, adjacent side. Yeah, because it's adjacent of hypotenuse. The hypotenuse is this 2, which is opposite the 90 degree angle. So the hypotenuse is there. And then you put the times. What is 10? 60. Tangent of 60 degrees. You come here. 60 is this one. Opposite of adjacent. Okay, 60 degrees is this one. So you're dealing with opposite of adjacent. So 60 degrees is this. Opposite 60 is what?
Square root of 3.
Square root of 3. Well done. Opposite 60 is the square root of 3 over, right, the adjacent. What is the adjacent? Adjacent, because the tangent is opposite of adjacent. Adjacent 60 is what?
1.
It's 1. Well done. Adjacent 60 is 1. Plus, what is the cosecant of 45? What is the cosecant of 45? Okay, let's come. Now, cosecant is going to come with, sine goes with cosecant theta. Cosine goes with sec theta. Tangent goes with cot theta. So that when you have cosecant or cosec, it is the reciprocal of sine. So you start and say hypotenuse over opposite for cosecant. Right, so you're going to look at 45 degrees. It doesn't matter whether you pick this one or this one. So when you're dealing with 45 degrees, then you're going to have 45 degrees and then say hypotenuse over opposite. Okay, because you're dealing with... So hypotenuse is what? Like if this is... Yeah, so it's the square root of 2. Right. So hypotenuse becomes the square root of 2. And then now this is the hypotenuse. You say hypotenuse over opposite. Opposite 45 is what?
1.
1. Well done. So you have the 1 here. But because this one is squared, what do? You square everything like that. Then you have the sine 60. Right, so the sine is opposite over hypotenuse. So the sine 60, 60 is this one. What is opposite 60? Because now we are dealing with sine 60, so sine is opposite of hypotenuse. Opposite 60 is what? This is 60. Square root of 3. Well done. So you have the square root of 3 there, opposite 60. Right. And because it's opposite of hypotenuse, opposite 6 is square root of 3. Hypotenuse is what? Hypotenuse, which is opposite, it is 2, opposite the 90-degree angle. So what is square root of 3 by square root of 3? It is exactly 3 plus. Okay, if you have the square root of 2, you square it. What do you get? 2 times the square root of 3 out of 2. And then now this is what you have. Let us proceed with this. So, right, we continue by writing here. So this 2 now, this 2 is going to cancel this 2. And then you have 3 over 2 plus the square root of what? The square root of 3. And this is the answer to this question. This is the answer to this question. So any question, anything that you do not understand, Paul? Anything that...
Final answer,
Yes, the key final answer, Anna. This one, this red one, is the final answer. Right, it is the final answer, this red one. It is the final answer. And then obviously, I mean, I'm going to give you another example right now. As part of what you need to learn, you must be able to remember your identities in trigonometry. There are some identities that you need to remember. Let us recap on those identities that you need to remember. Right, let us remember some of those identities. Right, there are things we call the tan theta. Tan theta is equal to what in terms of sine and cosine? Right, tan theta in terms of sine and cosine is equal to what? Yes, it's SOHCAHTOA that you need to use. It's SOHCAHTOA that obviously you need to use. Yes, so this one, but the tan theta, there are certain things we call the quotient identities. What are quotient identities? Right, they are quotient identities. The quotient identities tell us that tan theta is sine theta over what? Over cosine theta. And then what is cot theta? It is cot theta is cosine theta over what? Over sine theta. Okay? So now, if ever you have sine squared theta plus cosine squared theta, this is equal to what? This.
It's equal to formula formula.
That's fine. Sine squared theta plus cosine squared theta is always equal to 1. Always. It's always equal to 1.
1.
Yes, it is always equal to 1.
Like bakare.
Uh-huh.
Tan plus sin theta is over 1.
Okay. Yeah, but obviously, once they say sine squared theta plus cosine squared theta is equal to, it is always equal to 1. Always. But now, okay, yeah. But now they can give you tan squared theta plus 1. It's another identity. Tan squared theta plus 1 is equal to what? Tan squared theta plus 1 is equal to actually sec squared theta. And also there is a cot squared theta plus 1. Because now when you're dealing with the cotangent, when you're dealing with the cot squared theta plus 1. Cot squared theta, so you put co, and you put co here. You put co, and you put co. When you have tan squared, you put co, it becomes cotan. But cotan, we only write what? Cot. And then, if it is sec, you put a co, and it becomes cosec. And we write cosec squared theta. So we have this identity and also that identity. So the identity is that tan squared theta plus 1 is equal to sec squared theta. Cot squared theta plus 1 is equal to cosec squared theta. Okay, so but tan theta is sine theta over cosine theta. These are called quotient identities. Cotangent of theta is cosine theta over sine theta. Let us practice a little bit more. Let us look at more problems. Right, here is another question that we need to practice with. Let us look at this particular question. Right, in the next question, we're going to practice with many other things that that are important. That are important. All right, that are very important. So yeah, we have this. Okay, so we have the following. Here comes a question and it says solve for theta. Solve for theta. Okay, so you have 4 over 3. 4 over 3 sine theta is equal to cosine 37 degrees. Solve for theta. Okay, and the question continues. Let me just write it in full. When they say, right, solve for theta, correct. Correct to 2 decimal places. Correct to 2 decimal places. Okay, if they give you this one, what do you do here, Paul? What would you do? Okay, they give you this, but they also give you 0 degrees, theta 90 degrees. So what should happen now?
So, I tshwane le tse o qetang ho di etsa.
Yes, this one I tshwane obviously no, because now this one is a little bit different. We're learning how to solve for theta, so this is how we solve. So to solve this one now, we present a solution to this. Right, we present a solution. And the solution to this is that if you have 4 over 3 sine theta, which is cosine 37 degrees. So we cross multiply here. If you cross multiply, what do you get? Or what you do is you multiply by 3 over 4 on the left, because this is 4 over 3 sine theta. And then if you multiply by 3 over 4, you also multiply by 3 over 4 on the other side. 4 cancels and 3 cancels, leaving us with sine theta is 3 over 4 cosine 37 degrees. And then now we're going to use a calculator for this. We're going to use a calculator for this. So what you then do is you take this particular question and you use a calculator to find the result. Right. So you're going to write sine theta is equal to, so you use the this here. So it is actually 3 over 4.
So we punch in the calculating.
Yeah, we punch in so calculating. So you have a cosine. Yeah. So you say 3 over 4 cosine 37 degrees. 3 over 4 cosine 37 degrees.
Infa 0,57.
Yes, it's 0, comma 5.
57.
Right.
7.
Yeah, 5, 7. But yeah, I'm just getting 598.
Why?
597. Okay, I'm gonna check. I'm gonna check why this discrepancy. If need be, I'm gonna launch a calculator here. Let me launch a calculator so that we can get the same answer. Just 1 minute. I'm gonna launch our calculator. Right. Now, launching our calculator, this is what we're able to get. Right, launching our calculator, this is what we're able to get. Okay, let's get this calculator here. Right, so we have this calculator on the screen and we can see very well. Right, so, okay, so we're launching this calculator and we're gonna have the screen and we're gonna have this bar and we're gonna have this. Okay, let us use this calculator now because we want to be sure of the answer. Oops. Want to be sure of the answer, okay? So yeah. Okay, so now if you have this, you're gonna start by then saying here, if you have this, you have 3 over 4. You're gonna do this, and then you're gonna have 3 out of 4, and then you multiply. So you have 3 out of 4, you multiply by cosine 37 degrees. Cosine 36.
Maybe that's why.
Yeah, that's the thing. Because you see, yeah, you see what the calculator is giving us? It's giving us 0, 598,977. Can put 977 here like this. Okay, but you've seen what the calculator is giving us, okay? And then what we then do is we then continue to solve this one, which means therefore, if you use this, then you need to find something called the reference angle. What is the reference angle? So to find the reference angle of this, you need to say the reference angle is equal to, okay, there's something called the arc sine of 0,598,977. So that you have the reference angle is equal to, okay, now do this one. What is arc sine of this? Shift sine of this. What answer do you get? Okay, I'm going to also use our calculator here on the board. This calculator here.
Sana, how we actually
Yeah.
using a calculator. Oh, okay.
Yes, yes, eh? And then what answer will you get? So this is 0.5.
Mara ke etse
Uh-huh. What are you getting?
ke a e etsa.
Okay, yeah. It's in
Ke
degrees.
thola 0,64
Is your calculator in degrees or in radians? Your calculator. So you need to check that. You see, there's a small d, but very tiny here, and this is the degree symbol. So your calculator must be obviously in degrees. So that now you're gonna
Okay, ke etsa jang ebe in degrees.
obviously see I'll have to check the model of your calculator. Okay, but I'm gonna demonstrate with
Ke Tesla.
right. Okay, let's start. If you press on like this, you can do mode like this. Right. If you do mode, this is what you're seeing. So it's comp, stat, complex, and things. Then you can come here,
Yeah.
shift setup. Okay, shift setup. Then you can see degrees, 3, 4 is radians, and 5 is gradients. So now if you press 3, it's gonna be in degrees. So there's a small d there. There's a small d there. But now you can then do shift. Yeah, there's shift setup. Then you can, if you want to be in radians, it doesn't radians are not done at school, they're done at university. So there's 4, which is rad, R-A-D, rad. So if you press the 4 for rad, then there's going to be a small r there. And that is the radian symbol. Okay, but we don't want radians here because we're not at university with these things. We're just doing school. So we're going to do 3, 4 degrees. 3, 4 degrees. So if it is 3, 4 degrees, then you're going to do shift, sign. And then you have 0.5. Okay, so delete, point. So you have shift sign. You see how I started it? I said shift. Shift is this one. Then we have sign. Then you punch this number, 0 point. Right, 598. 598, 977. You close the bracket. This is equal to what? It is equal to 36.796666575. So you can say it is 36.79. Now, 2 decimal places, you can just say 36.80. So that's what I'm going to write here. Right, so we're going to write here 36. 36.80. Okay, good. Right, good,
Why
good, good.
ungola
80.
36,80?
Okay, yeah, let me write a bit more digits. We can write a bit more digits. Let me write a little bit more digits now.
Mo
So
anting nus na
it is 36 point. You can write 797. Okay, 36.797. And write like that. Right, 36 point. Right, 36,79 what? 7 degrees. Are we together?
yeah.
So what then are we able to achieve out of this?
Level
What?
6.
Okay, good. Yeah. So now, this sign is positive. It is positive 0.5. So you go to the cast rule like this and you put cast. Where is sign a positive number? Because this 0.5 is positive. Where is sign positive? In which quadrant is the sign positive here? Okay, all are positive here. So there's going to be an angle there. The sign is also positive there because this S stands for sign. This 10 means the sign is negative, it's negative there. So if the sign then is positive in these 2 quadrants, in the first and the what? in the first and the second quadrants.
Yeah.
It therefore means, therefore, that what we have is these are the two quadrants. So you need to find the angle. Okay, here is what they gave. The answer must be between 0 and what? And 90 degrees.
90 degrees.
0 and 90 degrees. So we're going to take this one. And then this one, not going to take it because there's 0 degrees here. There's 90 degrees there. There's 180 degrees here. There's 270 degrees there. And we have 300 and what? And 60 degrees there. So that in the end, if then you are looking, the answer must be between 0 degrees and 90 degrees. So between 0 degrees and 90 degrees, 0 degrees is here, 90 degrees is there. So it means, therefore, we can take our theta to be 36,797 degrees. 36,797 degrees. So that is the answer that we've got. But obviously, they said the answer must be correct to 2 decimal places. Right, so 2 decimal places means you need to say 36. You need 2 digits here. So the 79 is going to become 80. It's going to become what? 80 degrees there. So it is exactly 2 digits after the comma. Exactly 2 digits after the comma. Okay, right. So it was interesting to have in this discussion with you, Paul, but very, very exciting. We're going to meet over the weekend. I'm going to send you the time we're going to use during the weekend so that we can discuss, but late hours so that you can have time to play and play with your friends and go to the shops and buy bread and do a couple of things so that in the evening we can continue. Now the time is just 10:03 at night. Okay. And it's a very beautiful day.